Assalamualaikum and hi. Today our group, which is Group Dragon 4, will presenting engineering statistic group project presentation. So this is our team members starting from Muhammad Fakir Haziq bin Azman, Muhammad Alif bin Ghazali, Wan Muhammad Shakir Ramadan bin Wan Azman, Ahmad Solihin bin Muhammad Razi, and lastly Muhammad Hilmi bin Johari. So this group project containing introduction, data requirement, software, result, solution, conclusion, and reference.
Introduction. This project aimed to help Electrosia predict hourly electricity demand for Electrofania using 5 years of hourly consumption data combined with weather information. The dataset is splitting into training first 23 days of each month and test set remaining days. The challenge lies in predicting electricity demand influenced by measurable factors like weather and unmeasurable factors like human behavior. The goal is to develop a reliable predictive model using data analysis, statistical technique, and machine learning to optimize energy production, improve efficiency, and contribute to a sustainable energy system for Electrosia.
Next, I will present about our group data requirements. It is consist of electrical consumption of megawatt hours and date time. Next, I will present about the independent and dependent variables. Independent variable X of the total hour and the dependent variable is Y, that is electrical consumption. Time hours naturally influence electricity consumption patterns, not vice versa. This makes hours a logical independent variable. It considered dependent because electricity usage typically varies based on the time of day. Measuring consumption in megawatt hours is standard in power industry analysis.
So our group have decided to choose Excel from Microsoft as a software to calculate the data, such as to find the value of mean, standard deviation, minimum value, maximum value, and also to produce the graph. As we can see here, this is a table of data that we insert into the Excel and make a formula for them, and we get the value of mean of interval is 0.9667. For the electric consumption is 214.2. For the standard deviation, the value of interval is 0.1826, while for the electric consumption is 7.9616. For the minimum value for interval is 1, also same with the maximum value. For the minimum value of electric consumption is 198. For the maximum value is 231. Thank you.
My name is Ahmad Solihin bin Muhammad Razi. My matrix number is AE220021. Okay, for this graph, you can look at it. The graph for scatter plot and linear regression line, which is electric consumption versus the the total hour.
For linear regression equation, we can see that y equals to -0.1362x plus 216.17. And for the significant testing, from this formula we can see that beta 1 equals to -0.1362 and beta naught equals to 216.1742. For standard deviation of residuals, we can see that 7 is the standard deviation equals to 7.8675, and standard error for beta 1 is 0.1660. So for the statistic for beta, we can see that it is negative 0.8204, and this statistic for R is same as beta, which is negative 0.8204.
Let me interpret the graph for you. So the first one, the interception at 216.17 megawatt per hour. This represents the theoretical initial electric consumption when x equals to 0. It means the estimated consumption will be 216.17 megawatt per hour at the starting point. This is a realistic value as it falls within the range of observed consumption values 195 to 230 megawatt per hour. And for the slope, you can see that the negative 0.1362 megawatt per hour megawatt hour per unit. The negative slope indicates a decreasing trend in consumption over time for each unit increase in X time period. The electric consumption decreases by 0.1362 megawatt hour. This represents a very slight downward trend in consumption. For impossible events limitations, if this trend were to continue indefinitely, eventually the consumption will reach zero or negative values, which is impossible for electrical consumption. The R2 value of 0.0235, which is 2.35%, is very low, indicating that this linear model explains only about 2.35% of the variation in the data. This suggests that the linear relationship is very weak and the model may not be appropriate for making decision predictions.
So we move to the t-test for B0 and B1. First, we got the intercept value BO, which is 216.17, and its standard error of intercept is 13.95. For this statistic, we got from intercept divided by standard error of intercept, and we got 15.496. Next, we move to the critical value, which is alpha equals to 0.005 and degree of freedom is 28. And we can see that the 496 is larger than 2.763. So we reject the H naught. And in conclusion, there is a significant evidence to conclude that the B naught is not equals to zero at 5% significance level. For testing H1, we got the value, which is negative 0.1362, and its standard error of slope is 0.1705. And for t statistic, we got the value is negative 0.799, and the critical value we use the same, which is alpha equals to 0.05 and degree of freedom is 28. And same as for the intercept, we got the value, which is 2.763, and we can see that the value of t statistic of slope, which is negative 0.799, is lower than 2.763. So we fail to reject the H naught. And for conclusion, there is not significant evidence to conclude that the B1 is not equals to zero at 5% significance level. So for the residual analysis, the slope we got is negative 0.1362, and the intercept is 216.1742. For standard deviation of residuals, we got 7.8675, and standard error for B1 is 0.1660. The t statistic for beta is negative 0.8204, and t statistic for R is negative 0.8204.
Now let us look at residual analysis. If you look at the residual plot, the graph, you will see for the similar residual variances, looking at the residual plot, the spread of the residuals appears relatively consistent across different values of total hours. This suggests the assumption of similar variances is reasonably met. And if you look at the normal probability plot, you can see that the graph is taking like following points following close to the red reference line indicate normally distributed residuals. Minor deviations from the line suggest slight departures from normality. No systematic patterns in the plot suggest the residuals are independent. The spread of points indicates relatively consistent variance across the range. If you look at the independence of residuals, looking at that versus time plot, there's no clear pattern or systematic trend. And now we look at line fit plot. If you look at the graph, it says that the outliers, looking at the standardized residuals, most points fall within plus or minus 2 standard deviations. No point exceed plus or minus 3 standard deviations, and no influential outliers detected that would significantly impact the regression.
So for the Pearson correlation, from the formula, we substitute with its value and the result we got is negative 0.1532. And the coefficient of determination, which is the R squared, equals to 0.0235. And the outliers affect R squared by increasing R squared if they follow the pattern and the decreasing R squared if they deviate from the pattern. For R versus P, R is a sample correlation coefficient. It measures the strength and direction of the linear relationship between two variables in the sample data. P is the true correlation coefficient of the population from which the sample is drawn. It is unknown parameter, and hypothesis testing is used to determine whether P equals to 0, no correlation, or P not equals to 0, which there is a significant correlation. R is an estimate of P, and when testing for P, we use R as a proxy to decide whether P is significantly different from 0. So for the p-test, from the formula and we substituting its value, we got the test equals to negative 0.8204, and the critical value at alpha equals to 0.05, and the degree of freedom equals to 28. We calculate the P-value lies within the range of negative 2.052 to 2.763.
So for the model accuracy assessment, these are all the result that we already get from the Excel. We need to put the all the data into the Excel, and then we just need it to execute the summary output and also the residual output.
Conclusion. This project aims to build a model to predict hourly electricity demand in Electrovenia, helping Electrosia optimize energy production. By analyzing 5 years of data and weather pattern, the model will consider factors like temperature and human behavior. Using data, analysis and machine learning, it will predict future demand, improving efficiency, reducing costs and ensuring a stable supply.
For the references, we use the IEE citation styles.